Intro. Hey everyone, welcome back to the channel. We're diving into something fundamental yet incredibly crucial in the world of databases. Have you ever wondered how your bank ensures that your money doesn't go missing when you transfer funds, or how an online store makes sure you get your products after paying for them? The magic behind these secure and reliable transactions comes down to something called ACID transactions. If you've never heard of them or just want to know how work, stick around. Main content. So, what exactly are ACID transactions? ACID is an acronym that stands for Atomicity, Consistency, Isolation, and Durability. These are the four key properties that make database transactions reliable and trustable. Let's break down each property, shall we? First up is atomicity. Think of it as the all or nothing principle in transactions. When a transaction takes place, it should be completed in its entirety or not at all. Imagine trying to withdraw money from an ATM. If the transaction is interrupted halfway, your account must not be debited. That's atomicity in action, ensuring that incomplete transactions are rolled back. Next is consistency. Consistency ensures that the database remains valid before and after a transaction. It checks that all constraints, like account balance limits or product availability, are satisfied. If a transaction tries to violate these rules, it's rolled back to maintain consistency. This guarantees that databases store only accurate and reliable data. Moving on to isolation, this property deals with transactions running concurrently without interference. Imagine two people booking the last movie ticket at the same time. Isolation ensures these transactions don't conflict, and only one succeeds, maintaining database integrity. Different levels of isolation can be configured based on application needs. Finally, there's durability. Once a transaction has been committed, it's final. Even in the event of a power failure, the changes persist. Think of it as saving your work. No matter what happens, the data remains safe and secure. Let's see ACID transactions in action in a simple state. Consider a banking app where you transfer funds from one account to another. The process begins with a begin transaction statement. First, the transfer amount is deducted from the source account. Next, it's added to the destination account. Finally, a commit statement confirms the transaction. If at any point an error occurs, the transaction is rolled back, restoring the initial state. Now that you know what ACID transactions are, let's explore where they're used. In the banking sector, ACID properties ensure secure financial transactions. Every time you withdraw money from an ATM, ACID transactions update the account balance and record the transaction. The process is atomic, consistent, isolated, and durable, ensuring your money is secure. In healthcare, ACID transactions are vital for patient records. When a doctor updates your medication in the electronic health record system, accuracy and security are guaranteed. The transaction ensures the update is atomic, consistent, isolated, and durable, keeping patient information safe. In e-commerce, ACID transactions ensure customer orders are processed correctly. When you buy a product, the inventory updates with an ACID transaction. This guarantees your transaction is atomic, consistent, isolated, and secure. Outro. So, there you have it, a comprehensive look at ACID transactions. These properties are the backbone of secure, reliable database operations that power the services we use daily. If you've learned something new today or have any questions, leave a comment below. Don't forget to like and share the video.